This classwork on slope begins with us trying to find the slope from these graphs. What we're really doing is drawing a triangle for rise over run. So the first thing I have to do is figure out where are 2 points I know hit at corners. I tried to draw these graphs where it was clear where things were hitting at the intercepts, because in each graph the intercept is a clear point where it crosses over. It may be the case where something crosses over in the middle of 2 dashes. If you're looking at a graph and trying to find the slope from it, try and pick where the line hits corners so that you know it's happening at whole numbers values for x and y. That's the easiest way to draw one of these triangles and find the slope. But what I'm going to do is I'm going to say this is the rise and this is the run, because I see there's a point here where it intersects and a point here where it intersects. If I count the rise as I move left to right, I go up 1, 2, 3. So rise over run is going to be 3 over, I see how many I went to the right. I went 1 to the right, so 3 over 1. The first slope should be a slope of 3. For this, I'm going to draw in my triangle. Again, I meant for it to hit these 2 intercepts. So after I've drawn in my triangle, I see that the rise, well, as I read left to right, it actually goes down. So it went down 1, 2. So the rise is -2. When I then go to see how far I went to go that -2, as I count across, 1, 2, 3, 4. So it's -2 over 4, which, while correct, is not a fully reduced fraction. I need to recognize that 2 goes into both the top and bottom. So really, when I divide them both by 2, I should get a final answer of -1/2. Again, the key to finding these slopes is to understanding it as a change in y over a change in x, or in other words, rise over run. For number 2, A and B, we're going to be using the slope formula. The slope formula you absolutely can have written on a note card or in your notes when you're taking the test, when you're taking the final. Basically, everything in this class is open note, so don't be afraid to have that out. Just make sure you don't have other people there helping you when you're taking a test. Otherwise, feel free to use the book, feel free to use whatever resources. I also don't use other websites and stuff, but basically anything that you have from the class, your notes, anything else is fair game. That being said, here when we're going to do 2, 1 and 3, 2, find the slope between the points, we want to have the formula m equals y2 minus y1 over x2 minus x1. So in order to see what goes where, I'm going to label the points. They're always x, y. It doesn't really matter which one I choose as the first or the second point. It'll still get me to the same answer. But I'm going to choose the one listed first to be my sub 1s, the one listed second to be my sub 2s. That means that the formula tells me to take y2, which is 5, subtract y1, which is 1, divided by x2, which is 3, minus x1, which is 2. On the top, 5 minus 1 gives me 4. On the bottom, 3 minus 2 gives me 1, which means this slope is 4. It's sometimes useful to leave it as a fraction like this, 4 over 1, because really that's telling me rise 4 over run 1. But in general, I think the system would probably rather you say the whole number 4 than report it as 4 over 1. When I go to do the second one, m equals, again, I want to label my points x, y, x, y. This is point 1, this is point 2. So my m equals y2, which is -1, minus y1, which is also -1. Notice how I put that second -1 in parentheses, just to remind myself this negative times that negative needs to make a positive. On bottom, we have x2, which is 2, minus x1, which is -3. Again, I'm putting it in parentheses to remember that I need to make negative times a negative is a positive. So on top, this becomes -1 plus 1. On bottom, this becomes 2 plus 3. On top, -1 plus 1 gives me 0. On bottom, 2 plus 3 gives me 5. 0 over 5 is really just 0. When something has 0 slope, that means it's a y equals line. If I look back, I can see that the 2 y coordinates were the same. Since the 2 y coordinates were the same, it has to have a 0 slope. If the two x coordinates had been the same, then where we would have gotten the 0 would be on the bottom here. Since mathematically we can't divide by 0, we'd get an error for that, and we'd have to list the slope as undefined or no slope. So here when we're finding the slope of these lines in number 3, we have to take that into account. If we have a horizontal line, we can jump and say the slope is 0. If we have a vertical line, we can jump and say the slope is undefined. So we just need to remember y and x, which one is horizontal and which one's vertical. Y is a horizontal line, x is a vertical line. So for the slope of y equals 1, I'm going to write 0. For the slope of x equals -7, I'm going to write undefined. I'm doing it in capitals because that's what the instructions say, and the instructions are meant to match what you're supposed to do in the online system. We pick up where we've been given a slope and a point. With that slope and a point, we can graph the line. All we need to do is start by anchoring ourselves to that point. 3, -2 tells me I move 1, 2, 3 in the x direction and down 1, 2 in the y direction. So we now have a point where we can start from. Once we have that point, we need to view the slope as a rise over run. Since this isn't given to us as a fraction, but just a whole number, -1, we know that we can make it into a fraction by dividing by 1. What that tells me is this line is going to go down 1, right 1. Down 1, right 1. Usually I like to use the slope twice to make 2 points. Then draw the line best I can. If we're doing the same thing for the second question, 1, 0 means I move right 1 and I don't go up or down any. I now have a point that I'm anchored to. If I want to do a slope of 3, that's really an understood 3 over 1. That means I rise 3, 1, 2, 3, go over 1. I like to do a second point, so 1, 2, 3, over 1. If I now draw in this line, that should be my graph of the line. In question 5, it asks us to determine whether the lines through each pair of points are parallel, perpendicular, or neither. Only way to determine this is by knowing the slopes of the lines. If the two slopes are the same, then I have parallel lines. If the two slopes are negative reciprocals, I have perpendicular lines. And if the two slopes don't have either of those relationships, then I say neither. So let's start by finding the slope in the first set of points. I'm going to label them x, y, 1, 1, 2, 2. Let me go ahead and do that for the second points while I'm here. 1, 1, 2, 2. So my formula says I need to take y2, in this case 2, minus y1, in this case 4, over x2, 2, minus x1, 1. On top, 2 minus 4 gives me -2. On bottom, 2 minus 1 gives me 1. So I get a slope of -2. For this one, I start out with y2, -4. I subtract y1, 0. I divide that by x2, 0, minus x1, -2. On top, -4 minus 0 just gives me -4. On bottom, 0 minus a -2 is really 0 plus 2, which gives me 2. -4 divided by 2 gives me -2. So I've now solved for the slope of each line. The first one has a slope of -2. The second one has a slope of -2. At this point, I look at them and say, well, they are the same. When we have two slopes that are the same, that's when I select that the two lines are parallel.